Hello students, in this lecture we are going to see formula. Okay, we're going to do a formula for integration. This is also similar to integration by substitution. Is suppose you have a question where you're integrating par x with two other terms f of x plus f dash of x. If this is what you have, okay, then your result will be e power x f of x plus k. Okay, this is what you will have. Now let us look at a question so that we can solve this and see what exactly I mean by this. Okay, let us look at question number 26. Let me write it down. X e power x integral x e power x, then divided by x plus 1 the whole square, divided by x plus 1 the whole square. Now again you will see why it is important for you to know differentiation thoroughly when you do this problem. Okay, so now I'm going to split this term, this question or this whole term into these two parts. For that I need to keep e power x separately. Okay, we don't need a bracket here. I'm going to keep only e power x and I'm going to put a bracket where I will split it into two terms f of x and f dash of x. So let me write it first and then let us think together for 2 minutes how we would achieve that. How are we going to break this single term into two terms, that is f of x plus f dash of x? Any idea? Think about it for a minute. Yes. We can do this by adding 1 and subtracting 1. Okay, we can do this by adding 1 and subtracting 1. That is, look at what happens in the next stage. X plus 1 divided by x plus 1 the whole square. Okay, then this minus 1 that I've added, I'm going to keep it as a separate term. X plus 1 the whole square, close the brackets, dx. Okay, now these two terms get cancelled. What you are left with is e power x into 1 by x plus 1 minus 1 by x plus 1 the whole square dx. Now students, go back to the differentiation chapter and try to recollect what was the difference. See, I'm saying that this is my f of x function and this is my f dash of x function. Okay, so let me just go back to the differentiation chapter. Suppose I have a function 1 by x. What happens? This I will write it as x power minus 1. When I differentiate this function d by dx, what happens? Okay, when I differentiate this function, it becomes x power. First, I will be multiplying with this minus 1 into x power minus 1, which is nothing but minus 1 or minus x the whole power minus 2. Rather, I can write it as 1 by x square. So the differentiation, if f of x is this, f dash of x is minus 1 by x square. So that's exactly what I have here. If my f of x is 1 by x plus 1, then my f dash of x is 1 by x plus 1 the whole square. So what is my final result? It will just end up being e power x into f of x plus k. So that is what will be my final result here. So my answer will be e power x divided by f of x, which is x plus 1 plus k. This is my final answer. Okay. So now let us look at our options and see which one matches with that. Option A. So answer is option A. Now let us go to question number 38. So if you get a question, very often these kind of questions come in the exam. This e power x formula is very often tested in the examination. So this kind of question you can score full marks in the examination. Okay, then let us have integral. What is question number 38? Integral x minus 1 into e power x divided by x square. Okay, so let me write it down. E power x into x minus 1 divided by x square dx. Okay, so now what do we have here? So again, like I told you, keep the e power x separately. Within bracket x minus 1 divided by x square. Now we have to split this whole thing into two terms. Okay, that is f of x and f dash of x. How are we going to do that? E power x within bracket x by x square minus 1 upon x square. Now this sum is more simpler than the previous one. See why? E power x within bracket 1 upon x minus 1 by x square. So is this not what we solved here on the right hand side? Right? Look at this. So we have the same thing. If this is my f of x function, this is my f dash of x function. Okay. If this is the question, then my answer becomes e power x by x plus k, which is nothing but option, A without the negative. Now let us go to question number 39. Question number 39, let's take this down. E power x within bracket x log x plus 1 by x. Integral e power x log x plus 1 by x. Okay, dx. Now let us simplify this. We are going to split it. When we split it will become x log x by x plus 1 upon x, close the bracket, dx. Okay, so now we have integral e power x log x plus 1 upon x dx. Now this is your f of x function. When we differentiate log x, what do we get? 1 by x. So this becomes my f dash of x function. So my final result is e power x log x plus k. Let's look at the options now. Question 39, option A. So these are questions where we can score full marks. Okay, these are very easy questions. Let's go to 42 now. Okay, 42 is a definite integral question. So you can solve that as self-practice after we complete the definite integrals question. Okay, so this you can do it as self-practice after we finish the definite integrals. So this is what I have in this video for you. You can go back and practice. Is there any other? You can also try question number 44. Not only 42, 44 also you can try for your self-practice today. Okay. Good luck and see you all in the next video.